What's up, guys? Today I'm going to be talking about neuromechanical coupling, injuries, and sleep, and how they all fit together. So first and foremost, what is neuromechanical coupling? In short, neuromechanical coupling is how your brain talks to your body. That's a very superficial level explanation, but it really sums it all up. Neuromechanical coupling, right, is how our body, through neurological properties, our nervous system, orchestrates movement, and in turn causes our muscles to move in a certain way that we desire them to, so a motor pattern stemming from our central nervous system, and in return our muscles and joints send back neurological impulses to the central nervous system that allow us to understand where we are in space, and you have this feed-forward feedback system which is neuromechanically coupled. So neurologically, your body is all connected. Your limbs are not going to move without a neurological impulse. And so now we have movement patterns, which are, multiple joints moving in space over a given period of time. Our body has to orchestrate these movements. And when our body is not neuromechanically coupled in the most optimal, biomechanically efficient, safe, and favorable way that we normally do a movement, then we run the risk of having an increase in injury. And so when we look at sleep, for example, people go, sleep, and there's a lot of studies on this too, by the way, sleep increases our risk for injury. Yes, right? And people go, it's because you're tired. Well, what does tired mean, right? My opinion on that is that there's most likely going to be a perturbation in our neuromechanical system of the human body. And so what I mean by that is when we look at sleep studies, we see that there are decreases in reaction time, decreases in mental acuity, decreases in awareness and our ability to focus. And what this leads to is most likely a decrease in it's indicating, by the way, a decrease in our neuromechanical abilities, how well our nervous system is processing. That's going to influence how you're going to orchestrate a movement, right? If I'm neuromechanically decoupled, right, that system's perturbed, we have an increased risk of injury. And if you want to reference studies that are great examples of that, look at some concussion studies. They've shown that when people have a concussion, right, we know a concussion perturbs the central nervous system and the nervous system in general, and it forces the body to reorganize in a new manner. There's a study looking at how the lower body and lower extremities produce vertical stiffness, and post-concussion, they actually change the way in which the joints are producing lower extremity stiffness. We've seen that post-concussion, you're at an increased risk for injury, right? Concussions are multidimensional. And so what happens when you get hit, you have neuromechanical perturbation, right? The way your motor pattern is going to fire might slightly be different or perturbed. So your body has to figure out a new way to neuromechanically couple this movement system in order to perform the action. And so when we look at things like sleep, we look at things like concussion or anything that perturbs our neuromuscular system, that is where we are at an increase of risk for injury. And so looking at our body through the lens of neuromechanics, right, how our system talks to our body, you begin to see how different variables can affect the same system. Whether we're talking about a concussion, whether we're talking about how we introduce motor patterns and movement and injury, right? If you get an injury, your body has to now change the way we neuromechanically move in order to get around that injury. Say you have a sprained ankle on the right ankle. Your body has to find a way to get you from point A to point B. So maybe it's going to rely on less ankle dorsiflexion because the thing is swollen, and it's going to maybe somehow compensate through the hips, through the knee, maybe through the lumbar, right? And so now what's happening is our body wants to get us from point A to point B. It knows we have to walk to do so. So it's going to say, okay, go from point A to point B, find a way to walk again. And it's going to neuromechanically alter the pattern in which we have to do that. Now, when you go through a rehabilitation process, you're going to have, you're going to attempt to retrain this, but you might increase the strength, the integrity of the tissue again. But this system is now neuromechanically coupled in a way that's less efficient than it would be otherwise. So this is where introduction of different kind of environmental stimuli to challenge the neuromuscular system and the ability to couple through different motor patterns can be used in rehabilitation or quote unquote prehab to stress the system to get a positive adaptation to reduce the likelihood of injury. And so when you're looking at a lot of these studies, again, look at it from a neuromechanical standpoint. how is the nervous system influencing the way our body functions? And ultimately, everything we do starts with the nervous system. Now, I'm not going to say every movement is, pure nervous system power, because I think that's kind of undermining the physiological properties of the muscle itself. They work together. So neuro, meaning the nervous system, mechanical, meaning the structures which it act upon, act in unison to perform movement itself. Taking that into consideration, when we, again, looking at these different studies that we see, whether it's sleep, whether, possibly even nutrition, different types of stressors we have in the body, and that might compromise the way our nervous system is functioning. It's going to possibly compromise our motor patterns, our ability to be coupled, and eventually increase the risk of injury because we're not functioning in the optimal way. At the same time, an increase in risk of injury might also be associated with a decrease in performance because, again, we're not coupled in the proper way or the way we'd like to be coupled. So, sum it all up, we are neuromechanically coupled. Our nervous system talks to our body talks back to our nervous system. The way these things talk and influence and orchestrate movement is hugely important for how we perform. Understanding this, and most importantly, appreciating this, can allow you to select certain exercises, movement patterns, external stimuli that might challenge this neuromechanical coupling in a way that is more than just adding load or reducing load, right, in the sense of what we traditionally see in the weight room, but it can open up and broaden your horizons to think about it in a different way, especially in regards to what we call prehabilitation, avoiding the likelihood of injury. Adding these multiple dimensions and factors can help increase the robustness and resilience of that individual itself by ensuring, or at least making sure you're doing the best you can to keep intact the way the system should be neuromechanically coupled. Thank you guys, really appreciate it. Take care, and I hope you guys enjoyed.